Hi class, my name is Mr. Dowling. I'm here to teach you about how to do some drafting, some simple blueprinting using what's called a three-sided view. It's a very simple form of blueprinting, but it gives a lot of details and information. It's a good place to start if you're just learning how. Now before I get into actually how to blueprint, I'm going to show you the device we're going to blueprint. It's this nice little cute bird house that someone made for me years ago. And we're going to be blueprinting this. You might notice that it doesn't have exactly straight up and down lines. It instead has some sloped lines. That's going to be something that you're going to learn how to do in an easy way instead of a more difficult way. But first, before we get into how to blueprint, we're going to first set up your paper or your board. For you guys, you're probably blueprinting on a blank sheet of white paper. Now you might notice this blue line right behind me. And that's because it's a 45-degree angle line from my top right corner. Why is that important? You'll see it when we get to the final steps. It helps accelerate a lot of work and basically makes the last step, the top step, to be almost nothing. It's a few minutes and you're done. The first step, the front side, that's going to be the most difficult. It's going to take a lot of time. You spend most of the time on the front. That's because that's where most of the detail is. By the end, because of this and the previous work you do, it becomes real simple. Now, how do you set up your paper? Well, you're going to take your basic clean sheet of paper. Hopefully it's nice and empty. You don't want to have other stuff on it. But in order to get that 45-degree line right here, what you're going to do is take this bottom corner, bring it up to the top, like so. Now, you don't need to make a big old crease in it. You don't have to like color it in. You don't have to, nothing like that. Just lightly crease it to give you a 45-degree angle line. And ta-da, look at that, 45-degree angle line. This right here, even though it's faded, it's hard to see sometimes, that's okay. You just need to be able to know where it is. You'll see why, but that's how you set up your paper. Now, when we do any of our blueprinting, you're always going to want to lay it sideways. You want to make sure your 45-degree angle crease is in there. And we are not going to ever draw right on the edge. In fact, our first step is we're going to go up 2 centimeters and in 2 centimeters. Why? Well, main reason is this space over here is for overflow, or if we need to label numbers or things like that. Plus it looks a lot nicer when you don't have everything crammed up on the edge. So first step, now that you have your crease, I want you to go up from the bottom left corner, up 2 centimeters, put a dot, go over 2 centimeters, put a dot, and then make those dots meet right about there. I'm going to do it on the board here. Now for me, so while you're doing this, for me, I'm going to be drawing it a lot bigger than you are. How much bigger? About 5 times bigger. I'm going to explain why as soon as I get my little dot in the corner. So I'm going to go from the corner of my board here, over 2 centimeters, and up 2 centimeters. I just put a little dot, and that's all you should do. I'm going to be doing this along with you, so don't worry if it takes you a few minutes or you have to rewind, go right ahead. Now, after I've put that dot, you'll notice that once again we have that little bit of a border, blank space underneath. If you wanted to, you could extend the line all the way across the bottom. That's perfectly fine. But don't just draw it by hand. At no time should you ever be using your free hand. Every drawing on a blueprint is done with a tool. Either a compass, protractor, ruler, whatever. It's never done by hand. That's art, this is blueprinting. When you have to blueprint, things must be exact, or as close as we possibly can get them. Remember, in art, if you're off by just a little bit, the face looks a little off. In engineering, if you're off by 1 degree, someone's going to die in your building. So we need to make sure that we are nice and accurate. Now, as your first drawing, don't worry if it's off by a bit, if it's a little weird. You're learning. That's the point now. But we do want to make sure that we do the practice of using tools so that when you start becoming better or using this as a professional setting, you've already got the skills. If you want to draw the line all the way across, don't just put your ruler up. measure the other side of your paper up 2 centimeters, put a dot, and then connect the dots. Connecting the dot is so much easier. I dropped my ruler, that's fine. So as we do connect the dots, that makes things so much easier, and it's actually the first step of what I'm going to be teaching you before we even start drawing, of additive and subtractive blueprinting. And I'm going to say additive is hard. It's annoying. I know you're thinking, but 2 plus 2, it's so easy. No, it's actually harder. I'm going to show you by drawing a very simple brick wall by adding every single brick. First I draw my square, and then I draw another square, and then I draw another square, and another square, and more squares, and then there's more squares. Oh, gotta get the next layer up, squares, squares. More squares, they're kind of all stacked on top of each other. If you can see, it's not pretty. The squares aren't really all that the same shape, and they're all lined up on top of each other. And squares, bricks should be tapered off each other to get more stability. So this is hard, and even if I spend a lot of time on it, probably wouldn't be able to do it very well. It's a difficult way of doing any kind of thing. So you should never worry about adding stuff on. What we're going to do is we're going to subtract. We're going to go big and then bring it in. So instead of drawing a bunch of little squares, I'm just going to draw the whole wall. And then I'm going to subtract from the wall. So I'm going to just draw all my horizontal lines, and then, a couple vertical lines alternating around. And that's a much better brick wall. That looks more like a brick wall to me than what I had before. And this is what we're going to do inside this practice, is we're going to make big boxes that you're then going to cut parts off of or shrink in, so that way you can actually make it a lot easier to handle than having to try and get something at some angle added on. Just connect the dots. So now that you know how we're going to approach this, let's also make sure we have the proper labeling on your blueprint. All this stuff, even before we start blueprinting, oh my goodness. Now down in the bottom corner here, underneath your dot, you're going to put the word scale. What does that mean? How big is your drawing compared to the object? Now for you guys, you're going to do a 1-to-1 ratio. And you might think, if you were really on this, you're like, but Mr. Dowling, how do I know that it's a 1-to-1 ratio? That's a good question, person who just asked that. How do I know is because your paper is only this big. This is your basic 8.5 by 11 inch paper. Well, okay, how big is this thing? Well, you gotta remember, we're gonna do a 3-sided view. That means that I'm going to be looking at the front, the side, and the top. Now, what is the front? Man, that's up to you to decide, but you should choose the one with the most detail in it, the stuff that has the things you have to really kind of draw parts to. You can see this. I got shelf here, I got the floor here, there's some depth in here, these come at angles. So it's a pretty good way to start as the front. But how do I know that I can only fit a ×1 scale on this? Well, how wide is it at its widest point? Well, if I take this ruler and I measure it, and I can go from the widest point, it's about 3.5 inches. Okay, I can fit that on an 11-inch paper. Well, let's turn it sideways, because that's what's going to happen. You're going to have the front and your side. And I measure this, and I measure it to be, oh, it's 3.5 inches. It's a box. How nice. Okay, 3.5 plus 3.5. See, unless my math fails me, that's 7. That's less than 11. We should be able to fit it just fine. Awesome. At 1 scale works, a 1-to-1 scale. But what about if I doubled it? Okay, well, that's where the problem comes in. 3.5 inches times 2 is 7, and then I have to multiply it or add another 7 for the side. So this would be 7, and this would be 7. That's 14. It's bigger than the paper. It's not going to fit. Okay, well, why don't we go the other way? Let's make it smaller. Yeah, but then it's going to be too small to see all the details, and you're going to have to try and draw little itty-bitty lines, and that's not fun. So for you guys, 1-to-1 scale. Mine, I could fit 5-to-5 just fine. In fact, I could go up to like a 9 times bigger. I can't do 10. I measured it. It's too long. My drawing would be to here on the front and then over past here off the camera if I went times 10. So I'm going to do ×5 to make it so you can see it. You're going to do ×1. How do we write this out? Well, you write the word scale. That lets me know the scale. And then I am going to put a 5:, 1. You are going to put a 1:1. And you might think, what does that mean? Well, it means my drawing is 5 times bigger than the object. That means if you measure something on my drawing and you go, oh, look at that, it's 5 inches long. It must be 5 inches in real life. No, the scale says that it is only 1 inch in real life. That is how that works. Now, what if you were drawing something that was, say, way too big to fit on a piece of paper? I mean, what if I were drawing a car? That's really big. That's way too big to fit on this paper. Imagine trying to fit a car on this. Oh, well, then that's when you flip the scale. Then it wouldn't be like 5:1. It'd be like 1:10 or 1:25. That would say that every 1 inch on this is 25 inches in the real life. So whatever scale you put down here is telling me the magnification for this drawing. Mine's going to be bigger than real life, so mine is a 5:1 ratio. All right, after all that talking, after all that stuff, we're finally ready to draw. I'm going to take a look at my little birdhouse. I'm going to zoom it in here so you can see I've got this nice roof. Got some nice walls here. Got a floor. Don't worry about the thickness. Don't worry about trying to draw 2 lines for this stuff. Just draw single lines for right now. But how am I going to fit this on here? Because right now you see that angle and this angle and this angle and this angle. They don't make 90-degree angles. That's really hard to do in like drawing. I mean, imagine that. I'd have to take a protractor, a really tiny one. I have to put it on there. I have to find the angle of this line, and then I have to take that protractor and put it on here, and then I have to try and make. That's additive. We're doing subtractive. I'm going to instead imagine a big box that goes as tall as this object and as wide as this object, and it just goes straight up and down on the side. So that means I'm going to measure it at its widest, and I'm going to draw that over. Then I'm going to measure it at its tallest, and I'm going to run that up and measure wide again, and then connect the dots. So let's do the first step together. We're going to measure it at its widest. If you already remember, I said it was 3.5 inches, but we're scientists here. We're going to use the metric system because inches shouldn't be used in science classes. So we're going to be using the metric system for this one. And I'm going to measure it, and it's going to come out to 9 centimeters. And you might be thinking like, oh, you're being pushy on the metric system. Well, here's the thing. See all those little teeny marks? See how easy they are to separate? See this side with the bigger marks? What if I have something that's in between those 2 big marks? I can't draw that, but I can because these are closer. So this is just easier to use. It has more precision. So I measured it, it's 9 centimeters. So I want you to go from that bottom dot, and I made my scale name too big, that was my fault. I'm gonna go from that bottom dot over 9 centimeters and put another dot. Make sure that that dot is also 2 centimeters up from the bottom of the paper. Do that right now. You should have 2 dots, that's it. Don't connect it yet. If you did, that's okay. Because now we're going to connect them. Alright, hopefully you can see that. That is my line. Looks nice. I hope yours does too. I'm sure it does. Looks nice. Nice line. So what do I have here? I have a line. Yay! I have drawn 1 line inside a blueprint. Huzzah! But it's actually a pretty big first step. It's setting the groundwork for everything else we do. Now I already said, hey, we're going to measure it at its highest and draw up along this side. Why not over here? Because we can use the edge of the paper to make sure that we get a straight line. Unless you have like a T-square or a triangle that lets you do, 90 degrees and such, use the paper edge. So you're going to go up, and let's find out how tall this thing is. This thing is 9 centimeters tall. how nice. It's square. So I want you to go up 9 centimeters along the edge of the paper and then in 2 centimeters and put a dot. Once you have that dot, then connect the lines. The dots are important later, and don't worry about drawing them too dark either. We'll probably be erasing several of them. But the dots are helpful as anchor points to draw from in case we need to connect other points. All right, I have an L. It's a nice letter of the alphabet. So we have an L shape here. Hopefully yours is working out well. Remember, at any time you get stuck, pause. Don't forget to rewind. And if you just rewound, hi again. So I have this L shape, and I want to now make it into a box. I know that's not the shape of my birdhouse, but I'm doing subtractive, which means I'm going to make this big box around it, and then I'm going to chop pieces off. So I need to get a dot over here. The trick is, I need to make sure that they are nice and equal. The arms are equal. So I need to measure up 9 from here and over 9 from here to make sure that they hit each other. How do I do that? Well, there's a couple of ways you can do this. There's different ways. If you have a second ruler, you can always lay it across the side and use it as a T-square. But in general, draw a small dash over at the edge. So like I'm doing it from the top, you can do it from the side. I'm going to measure over, make sure I'm straight. Now I'm doing this a little bit eyeball. But I'm going to just very, very lightly mark a small line. Then I'm going to go from the bottom up, and I'm going to make sure, hey, is that line 45 away? It's not. You can't probably see it, but it's ½ centimeter off. That's horrible. Okay, so that wasn't straight. All right, well, I'm going to mark where it should be, which is right here. And now I can figure out, because look, now I got a dot. I got a dot right there, and I can make sure to see if that's 45 away. Oh, it is. I was too high. I didn't have a nice flat line on my ruler. That's okay, but I was able to correct it by using the other line. So now I can see that these two connect. So take a second and connect your lines. I apologize for the amount of my back that you will be seeing during this broadcast. I have a box! Go 2 dimensions. Okay, now what? I'm not done. Still got quite a bit to draw there. And hopefully you can see it. I might take a second to darken it in. Even when I'm darkening it in, I'm still using a tool. Okay, hopefully that shows up a little better. So I have a square now, but as you can see, this object is not square. I mean, if I kind of rotate it, it looks a little more square, but it's not square. It's a pentagon, 5 sides. So how do I figure out how to do all of this? And that's where the trick comes in. This is where we're going to take points and just connect dots. The first dot I'm going to try and connect is I'm going to figure out about one of these slopes. You can do whichever one you want. I'm going to start with this awning up to the top. Now the top's in the center, And I can measure it if I want to. I can measure it exactly out, figure out the middle point, but I can also tell you I've already done it. It's in the middle. Well, it was 9 centimeters. What's half of 9 centimeters? Right, 4.5. So I'm going to go 4.5 centimeters on the top and put just one dot. I put a dot halfway across. That dot is going to be a point where we're going to connect to another point. Well, what does the awning connect to? It connects to a point right over here. How far down is this? Well, we could measure it. There's the back side. We can go, oh, about how far down does it go? Well, it's about 4 centimeters above the ground. So that means, no, sorry, it's a 4 centimeter drop from the top. I read it upside down. So from the top down, it's 4 centimeters. Which means I'm going to make a dot on this side 4 centimeters from the top and a dot on this side 4 centimeters from the top. You can do that too. All right, now that you have those dots, remember, if I'm going too fast, pause. We're going to connect the dots. And if we did it right, it'll look nice. And if I didn't do it right, it won't look nice. And I am off by a little bit, so I'm going to fix that real quick. Sorry, the width of these things are throwing off my measurements. I was off by like half a centimeter. All right. Hopefully you have this quaint little sort of house looking thing. Now these lines here don't exist in this. So take a moment and erase them. Look at that house. Put a chimney on that, little door in the front, live there. We don't have a house that's for people, we have a house that's for birds. So I need to figure out the rest of this. And here comes a little more of the tricks. I'm going to zoom in so you can see this. You can see this line right here doesn't match with the awning. It actually is in a little bit. Well, how much does it go in? Well, we can figure that out. I'm going to take the ruler and I'm going to measure that. And I have to do it from my side. I can't do that with the camera. I tried. So we can see that it goes in. From the bottom of the awning, it goes in about 1 centimeter. So 1 centimeter in from here where that line meets up. So I'm going to, in case you didn't notice, there's also this cardboard right here, this line. So we're going to draw that too in a second. So I'm going to need to go in a little bit. But it doesn't match up perfectly. The drawing kind of, or the birdhouse has it kind of like this, which isn't right at this point. So that's kind of annoying and hard to do. But like I said, oh, we have this nice little cardboard right here, which is a straight point between these two sections. Now, there's a couple of ways we can do this. We already found out that this is 1 centimeter in, and I could find out how far in this subtracts, put the 2 points, connect the dots. But right now I'm thinking there's something an easier way. If I take this little piece of cardboard here, and I find out how far below it is, then I can just slice a line across this, and that's where these two meet. And then I can just draw down by finding out how wide this is. So let's do that way. So I'm going to figure out how far the drop is for here. And the drop looks to be, double check with the, it's about, I'm going to round up to 3.5 centimeters to make it easier for you. So 3.5 centimeters down from this point, we need to draw that line. Now I know if you haven't erased your line, I erased mine, it's kind of foolish, but if you can still see them, it's probably a little easier to draw 3.5 inches down from the corner here and put a dot and connect the lines, but I accidentally said erase them a little too hastily. So it's up to you. You can either do it by dropping it down here, but then you always got to be careful about over here. So if you can still see the lines, great. Measure down 3.5 centimeters. And just put a little dot. Then do the same on the other side. And connect the two dots. Now if you already erased your lines, go from the top and put a point down here. Then measure from the side of the paper and the top of the paper, or the bottom of the paper, to make sure that you're the right distance in. Just half of this distance plus 2 centimeters should tell you whether or not you're in there. Alright, now I got my line across here. These awnings go down at an angle, or sorry, the wall from the awnings. So how do I figure that out? Well, I need to make sure that I can tell the width here. I could figure out by, like, you know, measuring the total width and doing some other stuff, but I'm going to, well, I'm still going to measure the total length here, and then know that, well, it's in the middle. There must be an equal side missing here and an equal side missing here. The total, if you can see that, is about 9 centimeters. This bottom one is about 4 centimeters. Well, 9 minus 4, that's 5. And it's equal on each side, so that means 2.5 centimeters on each side. Math to the rescue. So you're going to go in 2.5 centimeters on this, on the left side and the right side, and put a dot. Alright, now that you got that dot, connect the dots. And we go up to the cardboard line. Okay, erase your extra lines. Oop, I erased a little too much. I almost did that freehand, that was bad. And ta-da, birdhouse. I know it looks simple, but you know what? That took a lot of work. You get faster as you do this more often. And switch pens. Okay, now that I've got that, now what? Well, that's our front side. And you might be thinking, but wait, Mr. Dowling, there's depth here, and that doesn't look like there's any depth here. This is a two-dimensional object. I can't represent going into the board. We do that by rotating it. So you're going to take your object and you're going to rotate it. And as you can see, by rotating it, I get to see some extra features. Like, these walls don't make it all the way to the front. And it's about as deep as it is wide. Okay, that's good, but I can't represent that here. That's why we use 3 sides. So I'm going to take this image and rotate it 90 degrees. But there's some tricks to it, some very nice tricks to it. One of the tricks is this. If I put my fingers like right here, and then I rotate this to the side, did my fingers get wider? Did this object suddenly grow in height? No, that doesn't make any sense. If it did, that would be like if you met someone from the side, they're like this, "Hi everyone, this is," and then they turn around and they just suddenly grow up. You know, that would be really weird to live in a world where you could be standing on the left side of someone and they look like this, and the right side, handsome. You know, it's just, well, imagine. I know, I don't have much to work with, but we need to make sure that when we rotate it, that everything that is in the y-axis or the heights all stay the same. How do you do that? Well, just draw lines across. I'm going to use a bigger ruler because I have a bigger board. You can just use the same ruler you're using. But take whatever point that there is any kind of flat line. So we have a flat line here at the top. We have a bit of a change in perspective here at the eave, right here. So you can see there's going to be a line right here, a line right here, and a line right here. So I'm going to take a line from up here, just draw it straight across, a line from underneath the eave, just draw it straight across, and the line from the base, and draw it straight across. Now if you are not experienced with drawing straight lines, you're afraid of making a little problems, measure from the bottom of the paper the height of the dot. Then go all the way over the edge of your paper and measure it to make sure it matches. Put 2 dots, connect the dots. It's not hard to draw a straight line with a ruler. It's hard to draw flat lines if you don't have the extra piece of information. So I'm going to do it a little more freehand to speed up the video. So you have to forgive me if it comes out a little wobbly or wonky. Oh, and don't start your lines like right on the dot. Give yourself a little space. We're going to be erasing them. For the awning one, it might be hard to get for a single point. So use both of them. Both of them make it into an easy straight line because it's 2 points. Then just give yourself a bit of a line, move the ruler, and do it again. Okay, now you should have these lines going pretty much all the way to the edge of your paper. My edge is right here, so my top one's not quite there. Now we're not going to draw on the edge of the paper. Remember, we want that 2 centimeter border that we had over here. So once again, from the edge of your paper, measure in about 2 centimeters and put a dot on each of the lines. So I'm going to measure mine in a little bit. So there's the edge of my paper. I'm going to go in about 2 centimeters and put a dot. 2 centimeters, put another dot. Just to not change things up, I'm going to go again 2 centimeters in and put a dot. If you look at our bird house, you can see that the back is completely flat, which means those 3 dots you just drew, connect them. I'm going to erase a few lines just so it's easier for you to follow me, but don't go erasing just yet. As we have learned, I might be hasty with the erasing. So now I got the back of the birdhouse, so I need to then get the rest of it. Now I don't have to make any more measurements on any kind of height because I already did it. It's right there. They're all right there. There. See? There. They transfer over. Don't have to do them again. Already did them right there. So let's look at this. I need to find out how high. No, I don't need to do height. I just need to find out how wide it is. How wide it is? Well, in case you don't remember, it's kind of square. We already measured it. It's 9 centimeters. So I want you to go from the back line forward 9 centimeters and put a dot. And I want you to do it again for the bottom one. And, yes, for the middle one too. You might have thought that I was going to talk about this little indent, but you can see that the awning here goes all the way to the front. So, once again, measure 9 centimeters and put 3 dots. Drawing lines, putting on dots. I'm speaking now 'cause the video's quiet. You could get bored and fall asleep, so listen to me sing and you'll wake up, 'cause I can't sing. Dee-lee-dee. Okay, so I got my 3 dots. I'm going to connect the 3 dots. Now, I'm connecting 3 dots now just to do the subtraction method. I know that there isn't actually a line here. If you don't want to draw it, well, you don't really have to. It's just sometimes easier to draw everything in a box and then subtract later. So if you don't want to draw this middle one, you don't have to, because that's not where that line is. It's back a little bit. But I'm going to draw it because it's easier to see on the screen. Okay. Now that you can see where the side view is, I'm going to get a few of these lines out of the way. You don't have to yet. I'm doing it so that you don't get confused or that it doesn't look really bad on the screen. There's that bit of ruin. Okay. I need to move this line back a little bit. How far back? Well, let's measure and find out. I know that it's 9 centimeters, but I also know that this whole little red part, we're going to measure that, and I can see that, well, it's not a really nice number. It's 7.6 centimeters. Oh, 7.6 centimeters, not a whole number. That's okay. That's why we use centimeters. Imagine trying to do that with inches. Trying to do this with inches, it's 3 and I don't know, something between the 3 and the next mark. What's this? Oh, look. Comes really nice. Nice to 7.567. Yeah, 7.7. Let's go with that. 7.7. So 7.7 centimeters. Measure 7.7 centimeters from the back here on the top, or the middle line, and the bottom line, place a dot. another right there. Connect the dots. It's like a children's book. All right, and once again, I know that this little line down here has actually got a little bit of thickness in it, but it's your first time drawing, so all of our walls are going to be just paper line thin, or pencil line thin. If you drew this extra line here, just erase it. And voila, we have the side of the birdhouse, along with the front of the birdhouse. We are 2/3 of the way done. Now what's left? Well, we gotta get the top. And well, normally you can see, oh, that's real simple, it's just a square. If you have a more complex device, this can get actually pretty difficult. Luckily, it's a simple device because it's your first one. But if you have complex devices, how do you able to get all that information up here? We just do the same thing we did when we brought this over to the side. I'm going to take anything that I can see from the top, that you can see from the front. So here's my front. This is what's going to happen to the top. So I can see this side of the top and this side from the front. Sorry. I can see this side and this side. I messed that up. This line right along here is this point here. This line along here is this point here. To clarify, I'm going to take this point here and draw it straight up, and I'm going to take this point here and draw it straight up, just like when we extended the lines over. So take a second to do that. If you want to make sure you have straight lines, measure from the side of the paper. This one right here should be 2 centimeters from the side of the paper, so you can make sure you get a nice straight line. So even I'm doing it, just double checking some stuff. You're going to draw it up decently high, but it won't go past that 2 centimeter border, so you don't have to go all the way to the edge. And we do the same for this dot. Now if you want to make sure they're straight, you know this one's 2 centimeters from the edge of the paper, you know this one is the 9 centimeters away from the other one, so just double check, is it still 9 centimeters away on the top? Okay, I've got 2 arms going up, let's do the next part. This 45-degree line comes into play now. See, I'm going to take any vertical line here and extend it up to that 45-degree line. So I'm going to do this one right here, it's probably easier to see on the camera. So I take this line, and I extend it up to the 45-degree angle line, which it just barely hits. Wow. I put a little dot. Just a little dot right there. And it bends the line. So now I draw across the paper. I do that same thing for the back. Little dot. Now, oh, my ruler's not long enough to reach all the way over there. That's okay. Try and get it as close as you can. Draw a line. And then use that line to make sure your ruler's still straight when you get to the other side of your paper. All right, so we have a box. Yeah, I mean, if you look at it, it's kind of a box, except it's missing something kind of important. You see, a line on a blueprint represents some sort of change in direction. So when we look at, say, the front here, or the side, you can, I know it's red and yellow, so it's pretty obvious that, there's obviously going to be, two different lines here. But color doesn't matter in blueprinting. What matters is that if I were to take this ruler and run it along the surface, I have to change its angle to be able to continue on. Same thing for the bottom here. I have to change the angle. That's why there's a bottom line. On the inside, that shelf has a change in angle. So the top also has a change in angle. Well, where's this located? Well, if you look at your drawing, you can kind of figure out where it's supposed to be. It's right there. So just extend the line up. If you're worried about it, you can always measure from the sides in. It's in the midpoint. Oop, my ruler moved a little bit. Erase your extra lines. Ta-da! You have done your first blueprint. You have blueprinted a birdhouse. It's not quite done yet though, because now you gotta put numbers on it. Now we've already gone through all the video numbers, so if you want to go back and watch them all. But you will need to tell me, or tell your teacher, how big these are. Not how big they are on the paper, how big they are in real life. So for me, this is 5 times bigger than the birdhouse, right? Look at that thing. It fits inside it. So I need to tell you how big it is in real life. Because unless you want to take a ruler to this and then go, okay, this was 45 centimeters and divide that by 5 and that equals 9. Okay, so the width is 9. No, you don't want to do that, and neither does the contractor or anyone else who's working with your blueprint. So instead, you tell me how long these things are on the actual object. So I can tell you that this is 9 centimeters. I can tell you this part is also 9 centimeters. Now there's actually like proper protocol to how to draw these, but we don't have the tools for that. So this part is going to be a little freehand. Probably still use the ruler just to make sure your lines are straight. But I've already written this as 9 centimeters. This is also 9 centimeters. But I don't have to label it because I already did. That's a reflection of this part. Yay! So that means that I don't have to measure the height of this over here where it's kind of difficult because it's in the middle. I can do it on this side where I have a nice area right next to it, the edge of the paper, where that 2 centimeter border should be. So then I can draw another spot here. And that's 9 centimeters. You see how this works? You can get a lot of information, and even if you have, as long as you have similar areas, you can just do it in one place. Like this indent doesn't show up anywhere else, so I need to do that here, but this base, well, I need to do it here too because this doesn't show up anywhere else. But the height shows up over here, the width and length show up here. I don't need to put that information on this one. It's already in the other parts of my blueprint. So what I would need to do here is tell me the width of this part, how long these little arms are. The width's already set for, probably the length of the shed. This is information so that if someone else wants to build it, they can. I hope this is helpful. Please make sure to talk to your teacher about whether or not you're turning it in. And if you ever have questions, please come by and ask. Bye.